Hi guys, in this video we're going to be learning about pressure and volume. We'll be looking at pressure and volume calculations and we'll finish with a summary.
So far, one of the situations we've imagined is that we've heated a gas that's in a box of a fixed volume. And in this case, heating the gas increased the speeds that the particles moved at and increased the pressure. Now let's look at a different situation where we're going to expand a gas at a constant temperature. So constant temperature here you can think of as meaning that the speeds of the particles aren't really going to change. Well, in this case, increasing the volume is going to make the particles spread out more because they have more area available to them. On the box on the left, the particles are restricted to be quite close to each other, whereas in the other box they are not. And we can see from the picture that the particles are going to collide with each other less frequently, and also they're going to collide with the container walls less frequently. And this is going to result in a decrease in pressure. Because remember, the pressure was all about the force on the walls due to the particles always bumping into the walls. So the important point to remember moving on here is increasing the volume decreases the pressure, and on the other side, decreasing the volume is going to increase the pressure. Now the mathematical way to describe this relationship is to say that pressure and volume are inversely proportional. That is, when the volume increases, the pressure decreases. And we can write this as an equation. And the equation might look kind of strange if you haven't seen this sort of thing before, but the equation is that the pressure multiplied by the volume is equal to a constant. And the way that this equation is related to being inversely proportional is easier seen if we rearrange the equation. For example, using a formula triangle or otherwise, you could show that this equation leads to an expression for P as pressure is equal to a constant divided by the volume. To see that this equation tells us P and V are inversely proportional, let's plug a couple of numbers in and see what happens when we increase V. Well, when V equals 1, P is just equal to our constant divided by 1, which is simply the constant. But let's imagine instead increasing the volume to 2.
Hey guys, to continue watching this video and unlock hundreds of other super concise and exam board specific GCSE physics and combined science videos, just click on the Snap Revise smiley face. Join me today and let's make physics at GCSE a walk in the park.